At the website thethirdwayofelution.com, over 80 eminent evolutionists declare their doubts about the modern synthesis. From the website, genomes merge, shrink, and grow, acquire new DNA components, and modify their structures by well-documented cellular and biochemical processes. Many of us see evolution as a complex process with distinct mechanisms and stages, rather than a phenomenon explainable by a small number of principles. About natural selection, they express their concerns regarding natural selection's scope and believe that other mechanisms are essential for a comprehensive understanding of evolutionary processes. About Ronald Fisher's genetic mutations, the DNA record does not support the assertion that small random mutations are the main source of new and useful variations. We now know that the many different processes of variation involve well-regulated cell action on DNA molecules. This disavowal of both pillars of the modern synthesis by prominent world authorities has been online since 2014. Yet the synthesis is still represented in schools as today's scientific account of human origins. Why is this? I don't know. The modern logic behind the modern synthesis has fallen apart. Take natural selection. For it to work, individual characteristics making for greater fitness would have to correspond to individual genes 1-to-1. But in most cases, they don't. Schrödinger pointed that out in 1944, and subsequent research has continually confirmed it. So why has the modern synthesis maintained any credibility? To explore this issue, I looked for a suitable title to review. Evolutionary theory in the form of population statistics has become exceedingly technical, way out of my reach, and that of humanities students, my intended audience. I needed something simple. I settled again on the primary spokesperson for the modern synthesis, Richard Dawkins, and a text of his, Climbing Mount Improbable. This text promises to address particularly our concerns. Dawkins declares himself infuriated when people of any eminence publicly express doubts about natural selection accounting for evolution. And he's out to show how wrong they are. So he's promising to marshal for us non-specialists just the evidence needed to make his case. That's exactly what we're after. As always, Darwin's writing is highly readable and full of examples of evolution's wondrous powers. No question, he's fully aware of them. But when it comes to how those wonders came about, he ceases being so open-minded. I see theories of evolution coming in three forms: the purely physical, those involving mind, and those involving God. Dawkins is, to the point of passionate obsession, a physicalist. For him, the world is purely physical. It's entirely bound by physical laws, along with defending today's combination of genetic mutation and natural selection. He's intent on ruling out any kind of theory other than the purely physical. Evolution involving only a purely physical mechanism that, above all, he is at pains to defend. To judge what Dawkins can tell us, let's begin by borrowing from the evolutionist Richard Schmidt. his distinction between microevolution and macroevolution. As Darwin first conceived of natural selection, its action was limited to selection among what Darwin referred to as races within a species. Schmidt referred to this as microevolution. It involves selection only for new combinations of variants, alleles, of existing genes within a single species. It can't create new genes or even new variants of existing genes. No controversy here. To some extent, evolution like this within a species is bound to happen. This we don't need Dawkins to explain. What we want accounted for is Schmidt's macroevolution. That's whatever's responsible for the origin of new genes, for the coordination of those new genes in ever more complex tissues and features, their expression being coordinated and maintained over generations in new kinds of creatures, while genes that aren't employed get lost as a consequence of disuse. If Dawkins can't make today's theory of evolution account for this, we're left without a workable theory. How does Dawkins do? In my opinion, he fails. He barely seems to try. Some chapters he devotes to simply describing evolution itself, of wings and eyes, for example, with no reference to mechanism. As is often the case with evolutionists, his logic seems to be living creatures evolve, natural selection is the only mechanism of evolution we have, therefore natural selection is how evolution works. Dawkins seems oblivious to the distinction between micro and macro evolution. His hobby of programming computers to mimic how evolution works seems to have accustomed him to asking very little of it. He gives an example involving spiders' webs. He does begin by giving us a measure of a spider's talents. Quote, a typical orb weaving spider produces 6 different kinds of silk from its rear end nozzles, made in separate glands in its abdomen, and it switches between the different types for different purposes. But to explore how amazing features like these evolved, he resorts to modeling spiders' webs as bioforms in his computer, little continuous line doodles varying in only 3 parameters, like horizontal, vertical, and diagonal. On these, he lets loose a computer version of natural selection. The resulting web-like forms, he claims, show that natural selection cannot be ruled out as a mechanism of evolution of spiders' webs. To me, this is no more than microevolution, selection among variations within species, by a computer selection process, no doubt 100% efficient. How can we make sense of issues like this? I have an idea. Remember Woodger and how he trained us in how to critique theories of evolution? Inspired by him and drawing on what I know about evolution and genomics, I composed what for me are crucial questions a theory of evolution should be able to answer. I will from here on ignore all Dawkins' book's other merits, seeking in it only answers to my questions. Here's my first Woodgerism. It's rather long. That's the point. You have to work down to the details. How many genes can natural selection select among? Suppose you start with a string of 3, each with 2 variants. In each subsequent generation, that's 8 possible variations for natural selection to select among, 2 times 2 times 2. So in each generation, to present natural selection with all variations to select from, you need at least 8 progeny. But remember, our authority on such matters, Ronald Fisher, gave natural selection an efficiency of only 1%. Now in each generation we need 800 progeny. Increase that number of genes to 4, each with 3 variants, as Dawkins did with his 3 parameters. Then for all 81 combinations, 3 times 3 times 3 times 3, to be presented to natural selection, your next generation needs to be correspondingly larger, 8100 progeny. Now suppose you want natural selection to specify the amino acids in a typical protein to be presented with all possible variants in thousands of nucleotides, not 3, not 4, each having 4 variants. The entire universe wouldn't be large enough to contain a generation including all the necessary progeny. That's the end of my Woodgerism, that's my query. So how can natural selection be the process through which such proteins arise? Dawkins acknowledges the challenge. Quote, "You don't need to be a mathematician or physicist, thank goodness, to calculate that an eye or a hemoglobin molecule would take from here to infinity to self-assemble by sheer higgledy-piggledy luck. The astronomic improbability of eyes and knees, enzymes and elbow joints and other living wonders is precisely the problem that any theory of life must solve." But he squirms out of the way. This is the kind of problem, quote, that Darwinism uniquely does solve. It solves it by breaking the improbability up into small, manageable parts, smearing out the luck needed. He seems to mean solves it by breaking down the overall challenge into a multitude of tiny, independent challenges, each small enough for mutation and selection to solve, that can each be carried out independently. But surely all the amino acids in a protein must be selected together in the right order. You can't break up the improbability as he suggests. You have to select for all the amino acids in order, not as separate tiny parts. I'm not satisfied with Dawkins' response to my first Woodgerism. My second Woodgerism asks, can natural selection account for new genes, for new features getting added to a living creature's genome? What does that involve? Here are my suggestions. First, code for a new gene is added to the genome, typically as long segments of code scattered along it. Then, a messenger RNA also has to be created, equipped to identify those segments, gather them together, recognize any inserts that need to be deleted, and delete them before that code gets delivered to a ribosome. Also needed is something able to send a signal saying, start executing that code. And in some cases, a system must be built into the body for delivery of the product to register when the necessary change has been carried out and to return a signal saying, turn the code off. For the gene to operate at the appropriate stage in development, it must be slotted into a schedule. And if it's specific to a particular tissue, it must be turned on there and off everywhere else. Finally, the code may have to be marked as conserved, that is, protected from further mutations. About all this, how new genes evolved, Dawkins tells us nothing. This part of the evolutionary process seems to offer no role for mutation plus natural selection. Rather, the process seems to call for well-regulated cell action, as thirdwayofevolution.com website puts it. How about the variations natural selection is supposed to work on? According to Ronald Fisher, those variations will typically come as random mutations, likely to single nucleotide bases. About these, here's another Woodgerism. Inside the cell, genomes are subject to a superb repair apparatus that eliminates all but a minute proportion of errors. Single nucleotide mutations would surely count among these errors, so all but a few would be eliminated. Any that remain probably involve bonds particularly resistant to repair, so they will no longer represent the full range of random changes. They would in effect have undergone selection by the cell itself, not natural selection. The repair apparatus may eliminate all mutations. Any changes in genes may be engineered by actions of the cell itself. Modern science simply defaults to assuming all changes are mutations. Of this super-efficient repair apparatus, how it limits expression of random variations, Dawkins in this book takes no account, though he does acknowledge this apparatus and its higher efficiency elsewhere, where I first heard about it. As for genes once formed being protected from further mutations, Dawkins does point out that sections of the genome vary in how much mutation they tolerate. Quote, mutations are also more likely to occur in some genes than others. There are hotspots on chromosomes where mutation rates are markedly higher than the average. Other sections of the genome, this is me talking, for example, those that code for the spine, tolerate no mutation at all. The mutation selection engine is disabled. This marks another instance where it appears to be well-regulated cell action, not selection among mutated genes, that lays down the law. To just what extent is well-regulated cell action the machinery responsible for evolution? Dawkins is not altogether insensitive to this issue of how figs and wasps manage their relations. He concedes, quote, the calculations are of a complexity to tax our largest computers, yet the computer that is performing them is not made of electronic components, not even made of neural components. It is not located in a particular place in space at all. It is an automatic, distributed computer whose data bits are stored in DNA code spread over millions of individual bodies, shuttling from body to body via the process of reproduction. For further information about this computer in the form of well-regulated cell actions, I refer you to James Shapiro's book, Evolution, A View from the 21st Century, that I've already posted a review of. For channels other than natural selection connecting the genome to challenges and opportunities posed by the outside world, I refer you to Dennis Noble's book, The Music of Life. My conclusion is, despite the many merits of Dawkins' book, I could not extract from it any answers to my questions. Maybe I asked the wrong questions. It's for you to judge. Maybe the modern synthesis was always intended as no more than a fig leaf to make physicalism respectable. Maybe, as the professionals subscribing to the thirdwayofevolution.com urge us, we should abandon the modern synthesis altogether. But if we do, we're back to square one with no agreed-upon theory of how we evolved at all, where Erasmus Darwin started. If so, if we agree we evolved but we've no idea how, then we cannot know what kind of a creature we are. Do we have minds? Can we be consciously creative? How free of physical law is our thinking? What limits does having evolved pose? What freedoms does it allow? Without a religion, without a theory of evolution, we can't know ourselves. Are you okay with that? Or is the devil you know, the modern synthesis, better than the devil you don't?